Good morning to all. This is Sumati. In this video, we are going to see about error detection and correction method available in computer networks. Errors. First, before going deep into error correction and detection methods, we want to know what do you mean by errors. When the bits are transmitted over the computer network or a transmission media, it is subjected to get corrupted due to some problems or interference. This corrupted bits leads to spurious data, and this when reaching at a destination are called as errors. There are many reasons for this spurious data such as noise, crosstalks, etc., which takes place during the transmission over a transmission media. Data link layer uses some error control mechanism to ensure that all the frames that are being transmitted are received with high level of accuracy. But to understand how errors is controlled, it is essential to know what are all the types of errors that can occur in computer nets. Basically, there are three types of errors. They are single bit errors, multiple bit errors, and burst errors. Single bit errors, that is the received frame has been corrupted only in one bit. If it is corrupted at only in one bit, then it is said to be a single bit error. Look into this example. Here, the third bit 0 has been changed into 1, so it is said to be a single bit error. The next one is multiple bit error. In the received frame, more than one bits are corrupted, then it is said to be as multiple bit errors. Notice that there's multiple bits are at different locations. That is, 0 is converted to 1 and 1 is converted into 0 and 0 is converted into 1 at different locations. This type of errors is said to be as multiple bit errors. The third one is burst errors. In the received frames, more than one consecutive bits are corrupted. Consecutive bits means simultaneous. Consequently, the bits must appear. Here, see here, the third one, fourth one, and fifth one are being corrupted. This types of errors is said to be as burst errors. Error control mechanism is the one which is performed in data link layer. It ensures that all the data frames that is being transmitted is received by the receiver with certain accuracy. This error control mechanism is a process that is performed by the data link layer to identify and retransmit the data frames that is being lost or being corrupted during transmission. In both of these cases, the receiver and the destination does not receive the correct data frame, and the sender or the source does not know anything about any loss regarding the data frames. Therefore, in such types of cases, both the sender and the receiver are provided with some essential protocols that are required to detect and identify such types of errors. Here, the data link layer follows a technique known as retransmission of frames to detect and identify and during transit errors. Each and every time the error is detected during transmission, particular data frames are retransmitted, and this process is known as automatic repeat request, that is ARR. Ways of error control. There are two ways of error control. One is error detection method and another one is error correction method. Error detection method, as the name implies, it is just detecting or identification of errors. These errors may occur due to noise or any other impairments during transmission from the transmitter to the receiver in communication system. Error correction method, as the name suggests, simply means correction or solving or fixing of errors. It simply means reconstruction and rehabilitation of original data that is error free. But error correction method is very costly and very hard. Error correction and detection. For both error detection and error correction method, the sender needs to send some additional bits along with the data bits. The receiver performs necessary checks based upon the additional redundant bits. That is, the sender adds some additional bits. That bits are called as redundant bits. This additional bits helps the receiver to check whether the received data is correct or not. If it finds the data is free from errors, it removes the redundant bits after passing the message to the upper layers. Error detection techniques. There are three main error detection techniques. One is parity check, checksum and cyclic redundancy check, that is CRC. Parity check, here in this parity check technique, an extra bit is added. That extra bit added is called as parity bit. This bit is added by counting the number of ones. If the number of ones is either even, then one extra one is added to make it odd in case of odd parity. If the number of ones is even, and in case of even parity, then the extra bit added is 0. In case of even parity, if the number of ones is even, then the parity value is 0. If the number of ones is odd, then the parity bit value is 1. In case of odd parity, if the number of ones is odd, then the parity bit value is 0, and if the number of ones is even, then the parity bit value is 1. Look at this example. Here the data frame transmitted is 1001101. Here the number of ones is 4. In case of even parity, it is already we have 4 ones, so it is even, so the parity bit added is 0. If it is in case of odd parity, the number of ones is 4, and hence we are adding, to make it odd, we have to add 1 as a parity bit. The receiver will simply check the parity bit by counting the number of ones, and if the parity bit is correct, then it ignores the parity bit and receives the data frames. Next one is the checksum. In this error detection scheme, a procedure is being adapted. There are 4 steps being adapted. That is, the first step, the data is divided into fixed size frames or segments. Then the sender adds the segments using 1's complement arithmetic to get the sum. Then it complements the sum to get the checksum and sends it along with the data frames. The receiver adds the incoming segments along with the checksum using 1's complement arithmetic to get the checksum, to get the sum, and then complements it. If the result is 0, the received frames are accepted, otherwise they are discarded. Let us see an example for this checksum. At the sender side, assume that the sender wants to transmit an 8-bit data, that is 1101001. The first step is to divide the data. Here we are having 8 bits, hence we are dividing the bits into 4 bits. The next step, step 2, add the segments. So using 1's complement arithmetic, we have to add the segments. So this 1101 and 0011 is added, and we get the checksum as 10000. Step 3 is to handle the carry. The carry bit, the leftmost one is added to the least significant bit of the sum. So the sum is 10000. In this, the carry is the leftmost bit. So the leftmost bit 1 is added with the, after removing the carry, we have to add it. So 000 is added with 1, so we get 0001. Then the fourth step is to calculate this checksum. Here we take the 1's complement of the result. So there we got 0001. The complement of 001 is 1110. This is the checksum. 1110 is the checksum. Hence, to the data being transmitted is along with the 8 bits, this checksum is also added. The 8 bits is added, this is the first 8 bits, and along with that we are adding this checksum 1110. On the receiver side, it will receive the data plus checksum. As usual, we are going to divide the segments. We divide the data into segments. So for 4 bits we are going to divide, and the next we are going to add all the data using 1's complement arithmetic. So we are getting 410. And step 3 we have to handle the carry. So at last we had 1, so that is the carry that is added. So we get 1111. Then we have to get the checksum. To get the checksum we have to complement this sum. 111 is converted is 1's complement of 111 is 000. So if we receive, the receiver will take the final decision based on this result. If the final result is all zeros, then there is no errors during transmission and the data is being accepted. If there are any ones in this particular checksum, then it signifies that an error has occurred during transmission and it requests for retransmission of data. Next one is cyclic redundancy check. The cyclic redundancy check is also called as CRC. It involves binary division of data bits being sent and by a predetermined divisor. This divisor is generated using polynomials, and the remainder bits are called as CRC bit, that is cyclic redundancy check bits. These bits are added to the data bits, and it is being transmitted. On the receiver side, it divides the same incoming data using the predetermined divisor, and there is no reminder that the data unit is assumed to be correct and it is accepted. Otherwise, it is understood that the data is being corrupted and therefore it is rejected and advised for retransmission. This is the bit being transmitted, and the predetermined divisor, that is polynomial divisor, is calculated for the both sender and the receiver. Here the 11001 is divided using the divisor 101, so we get the cyclic redundancy code as 10. This 10 is added with the data stream, that is 11001. So the receiver will receive 11001110. It is again divided by the divisor, so we get 00 as the remainder. Here we are getting 000 as remainder, so there is no error. If suppose there is any 1 here, then we mean that there is an error and the receiver will be rejecting the data and it will be advising for retransmission of data. This is error correction techniques. This error correction technique helps to find out the exact number of bits that have been corrupted during transmission as well as their location. There are two ways to correct the errors. They are backward error correction method and forward error correction method. In backward error correction method, the receiver detects an error in the incoming frame. It requires the sender to retransmit the frame. It is very simple technique and it can be efficiently used only where retransmitting is not expensive, as in fiber optics, and time for retransmission is relatively low. In forward error correction techniques, if the receiver detects some errors in the incoming frames, it executes error correcting codes that generates the actual frames. This saves bandwidth required for retransmission. It is inevitable in real-time systems. However, if there are too many errors, the frames need to be retransmitted. Error correction codes (ECC) is broadly categorized into two types, that is block codes and convolution codes. When using block codes, the message is divided into fixed site blocks of bits to which redundant bits are added for error detection or correction. In convolution codes, the message comprises of data streams of arbitrary length and the parity symbol are generated by the sliding application of Boolean functions to the data streams. Common error correcting codes are Hamming codes, binary convolution codes, Reed-Solomon code, low density parity check codes. Hamming codes, it is a block code that is capable of detecting up to 2 simultaneous bit errors and correcting single bit errors. Binary convolution codes (BCC), here an encoder processes an input sequence of bits of arbitrary length and generates a sequence of output bits. Reed-Solomon code, they are block codes that are capable of correcting burst errors in the received data blocks. Low density parity check code, it is a block code specified by a parity check matrix containing a low densities of ones. They are suitable for large block size in very noisy channels. Thank you.